Objective 3 is to identify all phases of the cardiac cycle, understand the origin of pressure, and describe the relationship between pressure and volume. Okay, pressure being the force being exerted by the heart, and volume being the amount of blood that's found in that chamber. Okay. Now, before we get into the actual details, I want you to remember something that was really stressed in that first packet. And that's the fact that valves open as a response to pressure gradients across the chamber. Okay, and what that really means is that valves are not muscular, they do not move on their own, right? We talked about, or we should have looked at 4 valves, right? The AV valves, 2 of them, and the semilunar valves, 2 of them as well. And they do not open or close on their own, right? They're not muscle, right? They're mainly connective tissue. And so what causes a valve to open and close is simply a pressure gradient. So in order for, say, the AV valve to open, the pressure in the atria must exceed the pressure in the ventricle. And so this is a very passive process. The pressure just forces that valve open. Okay, that's going to be really important in understanding the phases of the cardiac cycle. So we'll talk about the phases of the cardiac cycle. We'll talk about the different pressures in the atria and ventricle, and then we'll move on to talk about the volumes and then the heart sounds. Okay, so the cardiac cycle is pretty much the events associated with a single heartbeat. So what is happening in your heart in a single heartbeat, right? In one heartbeat, what do your atria look like? What do your ventricles look like? What's the volume of blood that's being moved? What's the pressures associated with these chambers? And that's what a single, that's what a cardiac cycle is. And so there are 2 main periods that we see with the cardiac cycle. There's systole, which is representing ventricular contraction. And then there's diastole, which is ventricular relaxation or filling, right? Ventricular contraction is systole, and filling or ventricular relaxation is diastole. Now, when we speak about the cardiac cycle, as you can see, we're really referencing what's happening in the ventricle. But understand that the atria are playing a part here as well. But we're referencing what the pressure looks like and what the ventricles are doing, more importantly, okay? So valves open passively, right, which I just mentioned, to the gradient. So the AV valve open when the atrial pressure exceeds the ventricular pressure, and then the semilunar valves open when the ventricular pressure exceeds the pressure in the vessel that's exiting the heart, okay? All right, so let's go through the phases of the cardiac cycle here, and I'll try to point out some of the anatomy, but hopefully you would have studied that first packet and you would have an idea of the anatomy by now. Okay, so the first phase is ventricular filling, and we really start the cardiac cycle in the relaxation of the ventricle. This is in the middle of diastole. And what's happening here is blood is being returned from the atria, that's coming from whatever veins. Remember, we're dealing with both sides of the heart when we speak about the cardiac cycle. So we have the left side of the heart, we have the right side of the heart, and so we have venous return coming in not only from our systemic veins, but also from our pulmonary veins. Right? So when I speak about the cardiac cycle, understand it's happening on both sides of the heart simultaneously, okay? So blood comes into both atria, and we start ventricular filling when that blood has spilled down into the ventricle. And at the midpoint of diastole, this is where we start that ventricular filling. So what we have is the AV valves open, right, which you can see here, and blood is moving from atria down into the ventricle. And towards the end of this ventricular filling phase, we have a brief period of atrial contraction. This is mostly a passive process, again, because of the difference in pressure, but towards the end, that's the attempt of the atria to squeeze that last bit of blood out into the ventricle, okay? So I'll summarize that again. We start the cardiac cycle, phase 1 in ventricular filling. This is the middle of diastole, or the middle of the filling of the ventricle. And what's happening here, blood is moving from the atria, again on both sides, down into the ventricle, through the AV valves, right, on both sides, and that is where we start this cycle off, okay? Our second phase is called isovolumetric ventricular contraction. And I want to explain what this term isovolumetric means. It means that during this phase, both of our valves are closed. So both valves are closed here. And what we see is that the pressure in the chamber is rising. Remember, I said that in order for a valve to open, the pressure in the preceding chamber must exceed the pressure in the chamber that's to follow. Okay, so what's happening here is that the pressure in the ventricles are slowly rising. Both valves are closed at this point, and we're raising that pressure in order to squeeze the blood out of the valve and into its corresponding vessel. So either into the pulmonary artery here or into the aorta on the left side, okay? So this is where we start systole, so we start the contraction of the ventricles, but remember, there are no valves open yet, so the volume stays the same. The volume doesn't change if the valves are closed because blood cannot leave or enter. So hence we have the term isovolumetric ventricular contraction. Okay. In phase 3, we have actual movement here. So now we have that pressure in the ventricle. It has risen enough to where it exceeds the pressure in the vessel that is following. And so we have the opening of the semilunar valves, right? The valves between the ventricle and either the aorta or the pulmonary artery, depending on what side we're on. And so now we force those valves open and blood can leave that chamber, leave the ventricle, and be pumped either into the pulmonary artery again or the aorta, okay? So remember the reason that we have this forceful ejection of blood, because the pressure in the ventricle now exceeds the pressure in that corresponding vessel, okay? So we have opening up of the semilunar valves, ventricular pressure is greater than aortic pressure or pulmonary pressure on the right side, and then the semilunar valves close at the end of this phase, right? At the end of this phase, because blood is leaving the vessel, right? The pressure is going to start going down, and when it gets lower than the pressure in the ventricle, that valve closes, right? It's really important for you to understand what keeps a valve open, for you to understand why it closes. It's going to close as blood leaves the vessel because now the pressure is decreasing, and if the pressure in the vessel gets lower than the pressure in the ventricle, the valve closes. All right, and so we have closure of the valve at the end of ventricular ejection. And then in phase 4, we have a very similar process to phase 2. We have isovolumetric ventricular relaxation. Again, here we have both valves closed. This is the beginning of diastole. So this is the beginning of the heart beginning to the beginning of the heart's filling phase once again. And so the ventricle starts to relax, but understand here, both valves are closed. So this is isovolumetric, meaning that our volume stays the same. So as the ventricle relaxes, that pressure decreases, the volume is remaining the same, all right? Now, we have no blood either entering or exiting the ventricle. So as the pressure in the chamber decreases, what is going to happen in order for the AV valves to open again? What has to happen in terms of the pressure for the AV valves to open again? So this valve. So during isovolumetric relaxation, the pressure in the chamber is falling. How low does it have to go in order to open up this AV valve? Right, by that principle of the pressure gradient, it has to be lower than the pressure in the atria, right? So the pressure in the ventricle must fall lower than the pressure in the atria so that now we have a higher pressure in the atria, a lower pressure in the ventricle, and we can force that AV valve open once again. So please understand what is responsible for the opening and closing of the valves. It's the pressures, right? The pressures. So ventricular pressure must drop lower than the atrial pressure, and that's what's happening in this phase. And then we start right over again at phase 1 when we open up those AV valves